This video is about finding volume of a solid revolution about x-axis. Method 1. Finding volume of a solid of revolution using a disk method. We have this function f of x. Rotate about x-axis. Then you will get this solid of revolution with a few typical disks indicated. We call this is a disks. And for radians will be f of x. That means y. This shows a family of disks. And this is a 3D model of the solid of revolution. This function is y equals e to the x power. Domain is from -1 to 1. I will show you how this function rotates about x-axis. Let me rotate this for you to see this rotation clearly. Volume of a solid by revolving about x-axis. We use this formula to figure out the volume. A stands for the area of the typical disk. The volume of the solid generated by a region under f of x bounded by the x-axis and the vertical lines x equals to a and x equals to b, which is revolved about the x-axis is volume equals disk area times dx from A to B. The disk area they give to you pi r squared. From the graph, you could say this radians equals f of x. So we can write down the definite integral of pi times f of x squared from A to B. Since pi is constant, I can take a pi outside. Definite integral of f of x squared from A to B. This will be the volume of a solid of a revolution about x-axis. What if we have two functions rotating about x-axis? Finding the volume of a solid of revolution using a washer method. The general formula in this case would be this area equals pi capital R squared minus lowercase r squared, where capital R is an outer radius and lowercase r is the inner radius. Like this function from here to here, that is a capital R. Then from here to here, that will be the lowercase r. Then this volume equals this formula. Or you can write down this formula. So when you have two functions rotating about x-axis, your volume equals pi times the definite integral, still r squared, but this r will be the outer radius. We use f of x stand for that. That minus inner radius will be g of x squared from A to B. Here is all the formula rotating about x-axis or rotating about y equals b. This formula gives to you two functions rotating about x-axis. This formula shows two functions rotating about y equals b. For this video, we only deal with the first situation, which means one function rotating about x-axis. Guided practice 1. Find the volume of the solid formed when the following are revolved through 2 pi about the x-axis. So for A, volume equals pi from 1 to 3, definite integral of f of x squared. So we plug in pi times definite integral of x plus 1 over x squared from 1 to 3. So we put into calculator, you will get 41.9. Here's the formula for you to use when you try to figure out the volume of a solid of a revolution about x-axis. For B, we still plug into this formula. Then we put into calculator, you will get 1.57 will be the volume. For C, still we use this formula. Then we put this into calculator, you will get 1.12. Let's go to guided practice 2. Show that the volume of a revolution generated by rotating the shaded region through 360 degrees about x-axis is this. We will divide this shaded area into two parts. One part is about y equals x squared, rotating x-axis from 0 to 2. The other part, it will be for this linear function, rotating about x-axis from 2 to 4. First of all, we need to figure out this linear function. Slope, say go down and go to right. Down 8, to the right 4. So we have slope equals negative 8 over 4 equals negative 2. Then I use this point as a x1, y1. So we have y minus 0 equals negative 2, x minus 4. Distributive property get negative 2x plus 8. That's y equals. So we get the linear function y equals negative 2x plus 8. Let's label. This is volume 1 and here's volume 2. After rotating about x-axis. So for the volume 1, you will get the pi times definite integral of x square from 0 to 2. Then for the V2 equals pi times definite integral negative 2x plus 8 square from 2 to 4. So we will work out this V1 and V2 separately. Then the total volume equals V1 plus V2. Let's work this out. So pi times. This will be x to the 4th power. Therefore, x 5th power over 5. Then from 0 to 2. You will get the pi times 2 to the 5th power, that is 32 over 5. Minus 0 to the 5th power over 5, that is 0. So basically, V1 equals this. Let's work out for the V2. You will get the pi times definite integral of negative 2x plus 8 squared. You will get the negative 2x plus 8 to the 3rd power over 3 times 1 over 8 will be 1 over negative 2. If we have a constant number like this, we can take outside. So we get these two multiply, that's negative 1 over 6. So negative 1 over 6 times pi. Then bracket, we have negative 2x plus 8, 3rd power from 2 to 4. So we get a negative pi over 6. We plug in 4 first. Negative 2 times 4 plus 8. Then do the 3rd power. Minus negative 2 times 2 plus 8. Do the 3rd power. We figure out this will be 0. This will be 4 to the 3rd power 64. So multiply by negative 64. You will get 64 over 6 pi. Reduce 32 over 3 pi. So V equals V1 plus V2 equals V1 equals 32 over 5 pi plus 32 pi over 3. That multiply by 5, multiply by 5, multiply by 3, multiply by 3. We have the same denominator, that's 15. This will be 32 times 3 is 96 pi plus 160 pi. So you get the 256 pi over 15. When you work out the definite integral, remember if you have a coefficient, you can take outside. This strategy will make work much easier. Let's go to guided practice 3. Find the volume of the solid of revolution obtained when the shaded region is rotated through 360 degrees about the x-axis. First of all, you need to figure out the outer radius. That will be capital R equals cosine x. The inner radius will be lowercase r equals sin x. Since we have two functions, you have to figure out this intersection. We know the sin x equals cosine x when x equals pi over 4, which means 45. So this point will be pi over 4. Now we plug into this formula. The volume equals pi times the definite integral. That's from 0 to pi over 4. Cosine x squared minus sin x squared. So we put into calculator, you will get pi over 2.